Alright, hello. This is a video for your lesson 1 and 2, mixed practice for Algebra 1. So finding mean, median, mode, range, histograms, and box plots from data sets. So I'm going to remind you how to find the values in number 1 by hand, and then I'm also going to remind you how to use Desmos to find those values a little bit faster. So the first thing you do when you get a data set is I want to put it in order from smallest to biggest. So I'm going to cross things off as I go. I start with 3. And then the next value I have is a 5. Then I have 2 6s, 3 7s, and then 8. All right, so first thing I need to do is find the mean. Remember that mean means the average. When you find the average of a data set, that means that you have to take all these numbers and add them up. And then once you add them up, you're going to divide them all by how many numbers you added up. So 1, 2, 3, 4, 5, 6, 7, 8 numbers. So you can do that. You can use Desmos to type those all in. I'll just use my calculator here real quick. So if I needed to do this by hand, I would take 3 plus 5 plus 6 plus 6 plus 7, 7, 7, and 8. So that would be 49. Divided by 8. And I get that the average is 6.125. Okay, that's a nice quick way to find the average. And again, in a minute, I'm going to show you how to use Desmos to make this faster. The median here, let's skip for a second. Let's do mode, because I'm going to cross things off with median. Mode is the number that shows up the most often. And here it looks like it's 7. 7 shows up 3 times. No other number shows up that many times. Range, remember, is your max minus your min. So here our maximum is 8, our smallest is 3, which means our range is 5. Now when I do the median, you need to find the middle number. That's what median means. So to find the middle number in here, I need to count in from the end. So I'm going to cross them off as I go. Come in 1. Come in a second one, a third, and then it looks like I'm stuck with 2 in the middle. So technically what you need to do is find the average of 6 and 7. 6 plus 7 divided by 2, because I'm adding up 2 numbers, which would be 13 over 2, which is 6.5. Or you could figure out, right in the middle of 6 and 7 is 6.5. All right, none of that was too hard to do by hand, but let me remind you Desmos, because sometimes you're going to have bigger data sets, and it's going to be a little easier to do this on the computer. So if you are trying to find statistics or values of statistics using Desmos, the first thing you need to do is put a table in. So you hit the plus sign, go to table. Under X1, that's when you're going to type in all of these values. You'll type in your 3, 5, 6, 6. Now, I typed my data in order from smallest to biggest, but it does not matter. You could have used the original data set and typed them in out of order. It doesn't matter. You don't need to do anything for Y1, because what you're going to do next is you're going to go into this second box, number 2, and you're going to do this to find the mean. You're going to actually type the word mean, put parentheses, and then X1. You're going to do X1 because you want it to match the X1 up above. All right, well, in this gray box, it tells you that your average is 6.125, which is what we had over here. I can do the same thing for median. I can type in median of X1, and I get 6.5, which again is what I had. You can't do the mode or you can't do the range on Desmos, but at least the mean and median you can get, and you can use it to either verify your answer or just find your answer from the beginning. Okay, so that should be a pretty simple one to start off with. Next, we have a data set about a list of U.S. senators and what age they assumed office. That means how old were they when they became a senator. Now, if you look at this data set, it is actually in order, but sometimes it's a little hard to look at data when it's listed that way. So I gave you a line where you could write out the data in order if it just helps you to see it that way. So I'm going to write it out real quick here so that we can reference this. Hopefully it'll all fit on this line. Alright, hold on one second. Let's move this. There we go. Now it'll all fit. Alright, so there's my data just listed out, because again, sometimes it's easier to see it when it's listed in one row. Now it asks us to find the 5-number summary. Remember, your 5-number summary is the minimum, quartile 1, 2, 3, and your maximum. Well, the min and max are the easy ones. Minimum is the smallest value. Maximum is the largest value. Now, quartile 2 is your median. So that's what we actually just found a couple of minutes ago. We can find that by hand by counting in from the ends. So if I count in from the ends, I'm going to do this. I'm not going to cross everything off, but I'll count it here. 2, 3, 4, 5, 6, 7, and then I'm stuck here in the middle between 50 and 52. Between 50 and 52 is 51. All right, now I need to find quartile 1. So what I do, remember when my quartile 2 and my median is between two numbers, I include those two numbers when I find quartile 1. So I split it in the middle. So I use the first half, that 50 of our quartile, in finding quartile 1. So now I'm going to cross these off to find quartile 1. I have to do the same thing. 3, and then I'm in between 43 and 44 to find this quartile. Right? Well, in between 43 and 44 is 43.5. Same thing on the other side. I have to include the other half of my median to find this quartile for quartile 3. So I cross off again as I go. 3, and then I'm in between 55 and 56 for quartile 3, which is going to be 55.5. All right, now, just like the last data set, if you wanted to speed this up, you could go to Desmos and type in your data set in the table. So I'm going to pause the video and I'm going to type that in really quick for you. You can do that if you want to as well. All right, now just like before, I have my data in a list in Desmos. Now Desmos will find you the quartiles for you. So let's find the median, because remember the median is quartile 2. So to find the median, you would do median of list 1, which is x1 here. Because remember, all the data is in x1 up above. Well, it gave me my median of 51, which is what we found over here. So let me highlight that. Now it also will find quartile 1 and quartile 3. Remember how to do that here. You can type in quartile. Now this one's a little different. You have to type in x1 and comma 1, because you're finding quartile 1 here. And it gives you the value of 43.5, which is what we had. If I wanted to find quartile 3, I do the same thing. Quartile of my list, and I'm finding quartile 3, which is 55.5. That's our answer. So you can use Desmos, or you can use find the quartiles by hand. It really doesn't matter. The hardest thing about using Desmos is you have to remember what to type in, but if you remember, you might as well go for it. Okay? Now the range is always max minus min. Here my max is 65, minus 34 is my minimum, and that is a value of 31. So the age range of senators is 31. The mean of this data set, well again, you can either add them up like number 1 and divide, or I would use Desmos. I would make this easier. So you go over here to Desmos. I'm going to type in box 2, mean of my list in X1. And it tells me that the average is 50. Okay. So that means that our average of the data set is 50. if I had to interpret it, I would say the average age a senator assumes office is 50 years old. All right, now again, remember, I did that on Desmos, but if you wanted to find the average without Desmos, you would have to add up all these numbers in the list, and those would add up very carefully to 800, and then you would divide by the number of senators, which is 16. Okay, so I'd count up how many people I'm adding up, which is 16, divide, and you would get 50 as your age. All right, so now they ask us to do a little bit more. I already have these answers typed in to save me a little time so I don't have to flip back and forth between slides. So I want to know, is there an outlier? Now, we talked in our class about finding outliers. There is a formula, and you will always be given this formula. It says you take the quartiles Q3, which here is 55.5, minus quartile 1. This is called the interquartile range, or the IQR. This interquartile range is 12. So that means from quartile 1 to quartile 3 is 12. Now I need to find boundaries. These boundaries tell us where the normal data is located. Anything outside the boundaries is considered extreme or an outlier. So this lower boundary takes quartile 1, which is 43.5, and subtracts 1.5 times your IQR. So when I type that into my calculator, I'm going to have 43.5 minus 1.5 times my IQR of 12. And this tells me that my lower outlier is 25.5. Now, to decide if there's a lower outlier, you look at your data set. Is there any number in our data set lower than 25.5? Well, it looks like the lowest is 34, so no, none of the younger senators are unusually young to become a senator. Let's do the same thing for an upper outlier. I take quartile 3, which is 55.5, plus 1.5 times our IQR. So I'm going to type that into my calculator, plus 1.5 times 12, and I get an upper bound of 73.5. 73.5 is still what's considered normal. So my maximum of 65 here is within that range. So there are no upper outliers. Well, now, using my 5-number summary and my information about outliers, I'm able to build a box plot. Now remember, when you build a box plot, you first have to build the box. And the box is built by looking at the quartiles 1, 2, and 3. That builds your box. So I put a vertical line at 43.5, and you can estimate here. And I'm just going to label it just so I know that this is my quartile 1. That's one part of my box. The other end of my box is 55.5, which is roughly around here. That's quartile 3. And quartile 2 is at 51, which is right about here. Okay? That turns into a box for you. That's your box of the box whisker plot. Now, because this box and whisker plot does not have any outliers, that means that my whisker on the left goes down to where the minimum is. So that whisker goes down to 34. My whisker on the right goes up to the maximum because there are no outliers, which is 65. If I were to look at the shape of that data, I would say that the box looks pretty even and the whiskers on either side look even. So I would say that that's a pretty normal, or you could say a symmetric distribution. All right, go ahead and flip your paper over and let's look at number 3. Number 3, we're going to do a very similar kind of thing here. We're going to look at the number of hits in a game of hacky sack. So when you're playing hacky sack, how many times can you bounce or hit the ball without dropping it? So again, the data is ordered here, but I'm going to take a minute and I'm going to put the data into order so it's a little easier to see. Right, so go ahead and do that on your paper now, if you need to. Okay, now just like the last problem, I encourage you to try to use Desmos to make this a little bit easier if you need to. I will also show you how to find the quartiles by hand. However, I'll do Desmos first, and it's going to be a lot faster. All right, so first I can do my min and my max. My minimum here is 2. My maximum is 13. So let's go to Desmos and let's type the data in, and then we will find the quartiles via Desmos, and then I'll remind you how to do that by hand. Okay, so I'm going to pull up Desmos here. I'm going to start a new table. So I'm going to hit pause for just a second. All right, now that I have my data typed into Desmos in X1, I want to find my quartiles. Now, remember, if I'm trying to find, I'll do quartile 2 first. Because quartile 2 is your median. So to find the median on Desmos, you're going to type median in, then X1. That tells you to use the list you made. And it says that the median here is 6. So I'm going to write down that my median is 6. And again, I'll show you how to find this by hand one more time in just a minute. To find each quartile, quartile 1 and quartile 3. Again, Desmos will do this for you. You're going to type in quartile from your list X1. Quartile 1, you type a 1 there. And you should get that quartile 1 is at 5. All right, I'm going to do the same thing, although I'm going to back up here, and I just want to find the quartile for quartile 3, which they tell you is at 7. So quartile 3 is 7. Now, if you don't like using Desmos, although I think that is way faster than what I'm going to show you, you can do this by hand. So let's find the quartiles by hand. You need to start with quartile 2, which means that you would come in here and you would count in from the end. So I'm going to just kind of lightly cross them off as I go. 4, 5, 6, 7. Oh, and then I end up with one term in the middle, which is 6. That does match what Desmos gave me. Now remember, when you're finding the quartiles, if you have one term in the middle, that is your median, you do not include it when you find the first set of quartiles. Now, if I'm using that, I'm just going to look at 2 through 5. Again, I'm going to cross them off as I go to find quartile 1, which ends up being one number in the middle, which is 5, which is what Desmos gave me. The other quartile, I do the same thing. I cross off the values as I go, and it gives me 7, which again is what Desmos gave me. That doesn't take a long time, but it does take a little bit longer than using Desmos. So you would use whichever one you want, just make sure you're accurate whatever method you choose. Okay, now let's determine if there's an outlier in this data set. So I need to find the IQR, again, your interquartile range, which takes quartile 3 minus quartile 1. Here my interquartile range is 2. To find a lower bound, I'm going to take my first quartile of 5 minus 1.5 times my IQR. You can use Desmos or your calculator to find this value. I'll do 5 minus 1.5 times 2, which gives me a lower bound of 2. So when I look here, I look at my data set. 2 is the smallest number in my data set, but it is not lower than the bound. So there is no lower outlier. There's nothing unusual about that. No lower outlier. Upper bound is quartile 3, which is 7, plus 1.5 times 2. When I type this into my calculator, I get that my upper bound is 10. So here, it looks like if I look at my data, that 13 is unusual. 13 is going to be an outlier because it is higher than the upper bound. Okay, so we're going to come back to, actually, let's make our box plot now since we're talking about it. Then we'll come back and do the other values. Okay? So this is what we just came up with. I just have it typed here. So for my box plot, I again always start with the quartiles to make my box. I put a vertical line at my lower quartile of Q1. I'm just going to label it so you remember what it is. I put a vertical line at quartile 3, which is 7. And another vertical line at the median, quartile 2. That becomes your box. Now, when you have a lower outlier, you take, or I'm sorry, we do not have a lower outlier. There's no lower outlier. So your whisker is going to go all the way down to 2. I have an upper outlier, and that upper outlier is going to get a star on your number line. Now, here's the thing. I need to figure out where the whisker goes, because the whisker does not go to the star. So what I like to do is I cross off that biggest number. I'm not looking at it anymore. My next biggest number is 8, which means my whisker is going to go just to 8. That is going to be your box plot. Okay. All right. Now, it doesn't ask this question, but what I would say here is because you have an outlier on the right, this is going to be a skewed right distribution. All right. Now, let's go back and answer the other questions. Okay, let's start with the mean, the average. Okay, you can, again, add up all of those numbers, and we would have to divide by 2, 4, 6, 8, 10, 12, 14, 15. So there's 15 pieces of data here. So if you add all those numbers up, you would divide by 15 to get your average. I'm going to use Desmos because, again, Desmos is faster. So I'm going to type in here, mean of x1. I get the average is 6. If you do your average by hand, you should get 6 as well. So again, you would add up 2 plus 3 plus 4 plus 5, all the way up, divide by 15, and you should get 6. This means, on average, you get 6 hits of the hacky sack per game. Okay? That's what that's average means. The mode, you don't need Desmos, you just look for the number that shows up most often. And it looks like, let's see, we have 4 5s, oh, and 4 7s. So you actually have 2 modes here. You have 5 and 7 are your modes, what shows up most often. So the way to interpret that is the most common number of hits in a game is 5 or 7. Okay, you're going to have either one of those. All right, now let's make a histogram. When you make a histogram, remember that you put data into ranges. And what it reminds you of here is if a data point falls right at the end of a range, you put it into the higher data set. So we're going to see that here in a second. Our ranges, we have to think about this, goes from here 0 to 2. That's why the 0 and the 2 are there. So I want to count up in my list how many numbers are between 0 and 2. Well, excuse me. That doesn't include 2 because 2, like this direction just said, falls right here on the end of a region. So I don't have anything that's less than 2, so nothing's going to go in that box there. But I do have data that's going to fall between 2 and 4. That means pretty much data that's 2 or 3. Well, between 2 and 4, there are 2 pieces of data. So your bar here is going to go up to 2. You can color it in if you want, you don't have to. Again, I don't include 4 in that data set because 4 is a boundary, just like it says. 4 would go into the 4 to 6 range. So if I count 4 to 6, that means everything that's 4 or 5, but not 6. So that'd be all these values here. And there are 3, 4, 5 of them. So this bar is going to go up to 5. Again, I don't include the 6 because 6 is in the next range. Right now I go from 6 to 8, which means 6 and 7. So this has 1, and then all these down here. 2, 3, 4, 5. There are 6 numbers between 6 and 8. So you're going to make your bar go up to 6. All right, again, I don't include 8 because 8 is down here and 8 goes into the next range. So I need 8 through 10. Well, the only number between 8 and 10, there's only one of them. So this bar only goes up to 1. And then I look 10 to 12. Well, I actually don't have any data points between 10 and 12, so I leave it empty. And then I look 12 to 14. There is one value here of 13. So over here, I'm going to put one more bar. Okay. Now, when I look at the shape of this data set, it kind of looks like, if I traced this, that it would be kind of pulled out towards the right a little bit there. So just like our box plot, it should be the same. I would say this is skewed to the right. There's a little tail pulling the data set over to the right. What column has the highest frequency? Well, that means which column is the tallest, and that is 6 to 8. There are 6 pieces of data there. What column has the lowest frequency? Well, that would be 10 to 12 because there's nothing in that column. It's totally empty. All right, let's practice a histogram one more time by doing number 4. Okay, sometimes it just takes a little bit of practice here for histograms. So we have a test of hand-eye coordination, and it says find the number of seconds required to finish a task. Okay, involving various putting shapes into holes. Okay, so they have 14 second grade students do this, and the data is listed there. So it says make a histogram of the data. Now I think the nice thing for you is that the data is already in order, which really helps when you're going to make the histogram here. So I'm going to start with my range 10 to 20. There are no numbers in this list from 10 to 20, so I leave it blank. Same from 20 to 30. There are no numbers between 20 and 30 here. So I start with the range between 30 and 40. Looks like there's only one value in between 30 and 40. So I'm going to make this bar go up to 1. Now I go between 40 and 50. There are no data sets up here, so I'm going to leave that empty as well. Between 50 and 60. Again, it just looks like that one guy, 59. So I'm going to make my bar go to 1. Now we get a little bit more data. 60 to 70. So between 60 and 70, I'm going to have only 3. Notice that there is a 70 here, but remember that 70 goes in the next range, next box. So I'm going to make this column go up to 3. All right, now I'm starting with 70. So that's 70 to 80. This 70 is included in there. So the 70 goes in the next box, but the 80 does not get included. The 80 is on the end, so it goes into the next one. So this one's going to go up to 4. All right, now I have 80 to 90. 80 to 90 here. If I look, 80 is included in this range, and it looks like next there are 5 pieces of data between 80 and 90. So I have that there. Now it asks for the shape of this data set. So if I drew a little curve over top of it, that definitely is pulled towards the left. So I would say that this is skewed to the left. All right, now they want to find the mean of the data set. Remember, mean is the average. To find the average, like we've talked about, you need to add up all of these numbers in the list. And then you're going to add them up and divide by the total number of data points, which is 14. However, as usual, it is faster to use Desmos. So we are going to go to Desmos, and we are going to type in, we're going to make a table, and we're going to type in all those values. So I have 31. So I want you to take a minute hit pause if you need to, and go type in the, oops, I typed one too many 76s. Type the data into Desmos for me. All right. So once you hit pause, unpause, you should be back. We're going to find the mean. Remember, you type in mean of x1, and you should get an average of 71. So the average here is 71. That means that it took an average of 71 seconds for a student to finish this task. If you found the average by hand, again, by adding up all the numbers and dividing by 14, you should also get 71. I'm going to find the median here. I'm also, remember, going to use Desmos because Desmos is faster. If I type in median of my list, it tells me that my median is 76. If you were going to find the median by hand, you would have to count in from the ends. So you cross off the first ones, 2 times 3, 4, 5, 6. And you end up here with two numbers in the middle. They're both 76, which means you average them and you get a median of 76, which is what Desmos told you. All right, the mode is the number that shows up most often. So if you look at your data set, it looks like 76 shows up twice, but also 83 shows up twice. So you have two modes. Finally, the range is taking your maximum minus your minimum. And when you subtract that, there's a range here of 54 seconds that it took students to do this task. All right, next one, number 5. You're given a box plot, you just have to interpret some information. So the first thing you need to know is, let's talk about a box plot. Remember, the box here is made up of the quartiles. Quartile 1 is the left part, quartile 2 is in the middle, and quartile 3 is the other part of the box. There are no stars, so there's no outliers, which means that the whiskers go out to your minimum and your maximum. Well, now that I've labeled my box, I can find all that information really easy. The median is Q2. Q2 looks like it's right at 15. My minimum here I labeled is at 7. Quartile 1 is at 13. The max here is at 18, and quartile 3 looks like it's at 16. The shape, if I look at this, it kind of looks like this left half of the data set is a little bit longer than the right half of the data set. So because of that, I would say that this is a skewed left distribution. All right, a couple more multiple choice here and we're all set. Number 6, you're given a box plot, okay? And it says this displays the scores that Algebra 1A students earned on their last unit test. What is the maximum score that a student earned? Well, you look to the box plot here. It looks like the maximum comes out here. There's no outlier on the right. So this maximum, if I came down to the table, is at 100. So they earned a score of 100. Is there an outlier? Well, yeah, there is, because you should notice there is a dot on that data set. That is your outlier. What is the outlier? It appears to be at 40. So one student scored really low on their test. They scored a 40. Otherwise, everybody else was considered normal. Then what's the median? Well, remember, the median is quartile 2 of your box plot, which is the line in the middle of the box. That's your quartile 2. And that looks like it is at 78. The scale's going by 2, so that line looks like it goes right to 78. All right, last couple here. I'm comparing box plots this time. It says, which class has a smaller range? Remember, the range is the maximum minus the minimum. So here, if I look at class A, it goes from 30 to, about 65 or so. But class B starts around 10 and goes up to close to 100. The range of class B is a lot bigger than class A. Class A's range, its max to its min, is a lot smaller than class B. Now it says which class has the larger first quartile? Well, the first quartile is the left part of your box, and we want to know the larger one. Well, if I compare, class B's is all the way up here at 60. So that is larger than class 1's, which is just past 40. All right, finally it says, what is the median for class B? Well, remember the median is the one in the middle, your quartile 2, the line in the middle of your box, which looks like it is up here at 80. All right, last histogram here. How would you describe the shape of this histogram? We've done a few of these today. Your shape here, if I drew a line over top, looks like it is being pulled out to the right. So I would say that that is a skewed right distribution. Then it says, what range did most people have? That means which column is the largest? Well, my highest column is the first one, which is between 0 and 2 heads. All right, if you have other questions, make sure that you ask your teacher for a little bit of help. But use Desmos, it will help you.